All right, so we're going to talk a little bit about how to find offspring P for the lab. A lot of people are having trouble with that one. So offspring P. Well, what is offspring P? And so if we remember from generally what we are looking at, P is the frequency of the dominant allele. So this is just what P is. In the Hardy-Weinberg equation, P is the frequency of the dominant allele. Well, what do we mean by offspring P? Offspring P is the result of your simulation. We're looking for the frequency of the dominant allele as a result of your simulation. And this means we're looking for the frequency of A as a result of our simulation. Okay, so we can kind of take a step back here again, similarly to how we approached question 18, and think about, well, what if I just gave you a different problem? If I said you had 40 A alleles in a population, and the total of the population was 100 total, 40A. How could you figure out the percentage, the frequency of A? And you'd say, well, that seems pretty straightforward. All I need to do is divide 40 by 100, because I know that's the amount of times that A would appear in the total. And so you'd get 40%. So that would be your P, your offspring P, for this problem. However, that's not the case in our lab because we want to generate an equation. So essentially, what we need to do is use what we've already calculated. We already know the total for the number of alleles in our lab because we calculated that. We also already know the number of A alleles in our lab because we calculated that. Those are numbers that we should have from questions 15 through 18. So what you need to do is write an equation, and so you can pretty simply say equals, and then find your cell where you have the number of A alleles, divided by the total alleles. Remember, this is going to be your equation, so you're going to find the cells that would go with this. But remember that you're not going to be using raw numbers. I should never see like a 20 here. It should only be cell names. So this should be K something, this should be K something as well. And so those should be the way that you find P. And if you're like, okay, now I have offspring P, how do I find offspring Q? Well, if we remember from our Hardy-Weinberg equation, P plus Q equals 1. And so if I want to isolate Q, I subtract P from both sides, so minus P, and I would get Q equals 1 minus P. And so I could put this into my next offspring Q as well. I could literally write an equation that says 1 minus P. And there you go. That's what you would put in for offspring Q, except for instead of P, you would also replace P with one of our cells, K something. Whatever you put in for offspring P, whatever that cell is, you just put in that cell name here for offspring P. And that gives you offspring Q. This gives you offspring P.